6.6, number 63. Solve. Answers are from 0 to 2 pi. Alright, so I've got a cosine of 2x, I've got a sine x. Cosine 2x, I can change that into sine versions. There's 3 different versions of cosine of 2x, double angle. So I could use this cosine squared minus sine squared. Well, that wouldn't be ideal. We'd still have to work at getting them all in terms of sine. This 1 minus 2 sine squared is the best one because 2 sine squared, because now we have everything in terms of sine x's. Alright, so I like to deal with a leading coefficient that is positive. It's a negative 2 sine squared, so I'm going to move everything to the right side. So I'm going to subtract 1, add 2 sine squared x's. Subtract 1, subtract 1. Okay, so this is what we end up with. So now we can solve. I'm going to pull out a sine x. Okay, so we end up with, okay, so I was just looking to see if I did something wrong because I can see where this is going. So let's just set each of those equal to 0, sine x equals 0, and I have 2 sine x. It was a little unexpected that I would get sine x equals 3 over 2. Well, we don't know what that is. It's not square root of 3 over 2, it's 3 over 2, okay? So when is sine equal to 3 over 2? Well, remember, sine goes from negative 1 to 1. It never goes above 1. So it's impossible that it would ever equal. Another way to look at it is you're trying to draw a triangle. If the sine of what angle has a sine of 3 over 2, so that would mean like opposite or hypotenuse 3 over 2. Well, that's not going to be true because the hypotenuse has to be the longest side, so that's impossible. So no solution for those. So now we're just at sine x equals 0. Sine is on the unit circle at 0. X equals 0, and pi because it's the y value.